And also the slides for this presentation are online under the link that I've put here, and I've also put in the chat. I'm just going to put it again in case it doesn't show up. It's just there's a lot of clickable links in the slides, so if you want to click on any links to look through after the presentation, then you can also download the slides already. All right, without further ado, let's get started with not the question that this talk is about, but another one, namely how to get a burger. So imagine that somebody has a store that has all the raw ingredients for a burger, and you're in a position that you want a burger. There's essentially two ways you can go to get a burger. The first one is get somebody else to make it for you, eat it ready-made, which is low effort for you, but also the quality of the burger will depend somewhat on the cook. So you'll be able to say cheese or no cheese, something like that. But in the end, the kind of burger you get really depends on the person cooking the burger for you. And so the second way that you have of getting a burger is to make your own from the raw ingredients, which probably have been packed for your convenience by the store, but not much else. The reason I'm telling you this is because I think it's a really good way of thinking about our data as well, and the two views that you can get on our data. So essentially, the data that we store in our database in our internal format, which is JSON, is the raw ingredients. And if you want to work with those ingredients, there is, again, two routes of doing that. One of them is sort of comparable to the ready-made burger, which is our web interface. And the other one is more like working with the ingredients that have been packed up, but nothing much else, which is working with what I call the serializations, which basically means any download version of our data in any of the various formats that we offer. Now, the web interface is something that we develop and maintain, and what we try to do there is provide something that has a lot of usability for human users, and that is a very generalistic tool. So we're trying to make it so that whatever kind of task you want to do, you can somehow do it in the web interface. That is, of course, always restricted. It's restricted by available technologies. That's the same if you try to work with the data yourself. It's also restricted by CERL development resources. So the web interface very much depends on how much money and time we can pour into it. And it's also somewhat restricted by earlier design decisions. So once we set on a particular course for the web interface, then those choices sort of percolate down in time, and it gets harder to change things afterwards that go in a different direction. So for that reason, sometimes it makes sense to work with the serializations instead. And the aim there is to provide you with machine readable data. So data that is in some way processable by computer programs, and that can be used for building your own tools or using your own tools if the web interface for some reason doesn't do what you want to do. That is again restricted by the available technologies, and also sort of in parallel to the web interface by your own resources. Do you have people who can do that? Do you have the technical skills? Do you have the domain skills, and so on and so forth? So most of today's talk is going to be about the serializations and what you can do with them, but I do want to start with the web interface. And what I want to show you is first what it does really well, what you can sort of do with it, because you can do a lot with it. And then I want to move on to what it struggles with and why we want to move over to working with the serializations, working with the raw data in some cases. So what a web interface does really well is you can search for records in it in a fairly sophisticated way. So we have both full text search and we have search in specific data fields. And there's also a fairly sophisticated search syntax behind all of this that's powered by our underlying search engine, which is Elasticsearch. And if you've never made much use of the search capabilities, I do absolutely invite you to check out first the MEI searching guidelines, because they are really good documentation of how you can search in one of our most complex databases in MEI. And also maybe the Elasticsearch documentation, which is a sort of more abstract view of what you can do with any Elasticsearch powered search interface, so also with our search interface. What you can also do once you've found a few records that you're interested in, you can filter them further by the predefined facets that we offer. So for example, if you find a lot of hits in a database, you can also say, okay, I'm now only interested in those by a particular hosting institution, and sort of filter them down. And once you've arrived at a data set that is really the data set that you want to work on, what you can also do in the web interface is display and edit records in a document-like view. And what I mean by document-like view is basically as if they were on a page, basically presented for human consumption. So what it does, what a web interface does, it shows you all the information that's available in a record in one display. And it is very much aimed at a human reader who then intelligently extracts the needed information from that view. So there is a certain assumption baked into that, namely that you're working with a small number of records and that you can still do the work of intelligent extraction for each one. Let's say you're interested in book purchases, and so you're looking at purchase prices in MEI, then the idea would be that you're looking at maybe 10 or 20 records and looking through the information and sort of intelligently getting it out of those records. But that gets a lot harder when you try to do that for, let's say, 1,000 records at a time, 2,000 records at a time, because that is where the web interface sort of reaches its limits. Just to highlight the ways in which the web interface fulfills those aims and is geared towards human users, some of the features are displayed on this slide. So, for example, the data format itself has labels for each of the data fields, and what we try to do for human users is we try to provide multilingual labels, translations of those into our users' native languages, so that it's easier for you to work with the data without always having to do this work of translating the data field name into the concepts that you have. Another thing that we do, which you can see here on the right, I think. So I always mix it up, how this is sort of in presentations. What you can see here is, for example, we pull information from other databases into the display of the record. So this is an MEI record. The MEI record doesn't really have information on the author and title of the book. What it has is only the ISTC number, which is really good for machines because they're happy when they have a unique identifier. But since human beings prefer identifying things by identificatory information like author and title, what we do for the display is we take the ISTC number and then pull in additional information that we display to the user, even though it's not in the record. And then one other element that we have in the interface is that we try to group related information visually. Again, this is for helping people who are looking at the records and trying to make sense of them. Machines don't really see this information in the same way. Now, where the web interface reaches its limitations, where it struggles a little bit, is first of all, it's not that good at filtering records based on more complex criteria. So the search syntax, the way that you search for records in the database, is based on the presence of information in particular data fields, but you can't usually describe more complex data structures. Just to give you a concrete example, if you're, for example, looking for information on purchase prices in the 16th century in MEI, the search can show you documents that have a 16th century provenance, and they can show you, it can show you documents that have information on purchase prices, but what it can't give you is whether the price information is in the 16th century provenance block. So you'll also end up with documents, say, that have a 16th century provenance without any purchase information, and then they have a 15th century provenance where there is a purchase price, because the search can't really distinguish between the two. So this is one of the things where the web interface can't really help you. The other one is, once you start working with your records and you want to display them and edit them, you always have this very generic interface with a lot of information in it, and you can't really modify it to work on particular tasks. The reason for that is because displaying a record, as you maybe have seen in a previous slide, is really a non-trivial task. It always requires decisions about how to map the data model to a human readable display. And so we can really only provide very generic solutions. And so a lot of the time, the users and editors end up doing the sort of cognitive labor of ignoring the data that they don't really need for the task of whatever they're doing at the moment, or for example, for adding data from external sources. So this is something that's not easily done in the web interface. Just to give you a particularly bad example, this is the CERL Thesaurus record for London in its entirety. And if you think about the size of your browser window, it usually stops roughly below that first block of blue items here, and then everything else below is just scrolling, scrolling, scrolling down until you reach the information that you're interested in to edit it. So this is one of the points where you sort of run up against this idea of presenting all the information to the user, because then you have to sort of do the work of going through all this information and picking out the one that you're interested in. So for this reason, sometimes it really makes sense if you have particular tasks that you want to do with our data, if you are interested in particular parts of the data, to switch from the web interface to our second option, which is taking the raw data and then either using your own tools or building your own tools for working with that data. And that covers a wide range of options. So this can mean that maybe you have a favorite spreadsheet software, let's say Excel, and you want to integrate the data with your existing workflows in that spreadsheet software. But it can also mean that maybe you want to write your own Python script to produce statistics on a set of CERL data. So it's a huge range of things that you can do with data. And of course, they come with different requirements in terms of technical expertise. But one thing that I want to stress here is that whenever you go beyond the web interface, you will probably need input not only from technology experts, but also from domain experts, and to different degrees, depending on the task and the available tools. And of course, the tools are also not mutually exclusive, but I think this is really something where everyone has to work together to produce something that works, because our data is not trivial. It's sort of very specific, particular kind of data that you sort of have to have some domain knowledge to also understand what's going on in the data format. So if you want to do that, if you want to go beyond the web interface, what do you need? So one of the first things that I think you have to do, and this I think is really more on the domain side of things than on the technology side of things, is you have to understand that a web interface does not and cannot really perfectly present the data model. It's always a translation of the data model into a visual display that's intended for human beings. But what it often does is it sort of informs our own mental models of the data. So we're familiar with the web interface, and so the way we think about the data is sometimes structured by the way that it's presented to us in the web interface. So a first step in working with the raw data is developing a more precise mental model of how the data is structured, and also mapping that to your own mental models of the domain. Sort of match up your concepts of what's going on in early modern book history with the information that we have about early modern book history in our databases. So just as an example, as let's say a book historian, you probably have a fairly complex mental representation of a book purchase. There's people involved, those people exchange books, they exchange money, all of this is situated in a particular place at a particular time. And as a human being, you can also easily manipulate this mental model to ask questions centered on particular elements of the representation. So you can, for example, ask questions like, what about prices within a particular date range? What about purchase prices in the 16th century, let's say? And so what you have to do if you want to start answering those questions based on our data is you have to see how your mental representation corresponds to the data model. And that is essentially a four-step process, which I'm going to illustrate on the next few slides. So the first thing that you have to do is you need to find the corresponding elements in the data model. So you have to figure out what kind of information am I interested in, and how is that information represented in the data? What kinds of data fields do the databases have? Where is the information stored? What's the format of the information? Those kinds of things. Then you have to diagnose how they are related by structure. So our records all have a tree structure. They are sort of nested hierarchies. And so in order to sort of see how the relation is interrelated within the record, you have to understand the structure and how elements fit together within it. And then once you've done that, you also have to understand whether the combined information of data elements and structure can answer your question, whether that is sufficient information for whatever question you're asking. And then, and I think that's one of the most important steps, make a decision whether you need to enrich or simplify the data for the task at hand. Now, to give you a concrete example of these steps, let's say, again, we're interested in book purchases in the 16th century. Now, if we have a look at the actual raw data, not as it's presented in the web interface, but as it is in one of the serializations, in that case, the serialization that corresponds with the internal format, the JSON, you can sort of see, all right, we have elements in the data model that correspond to the kinds of information I'm interested in. We have a price currency field, we have a price amount field, we have fields for time periods starting and ending. So this is sort of the first step, identifying these pieces of information within the data model. You can then go a step further and see that all of those elements are grouped in a single provenance block. So if you think about a tree structure, they're essentially siblings. They are branching off the same provenance block. And once you have that, you can sort of say, okay, so the data can answer my question about prices in the 16th century, even though the search function can't straightforwardly, but it is in the data because I'm basically looking for price currency and price amount fields that have a sibling that is a time period start and end field. And once you've done that, you can move on to steps like simplification and enrichment. Now, a standard case of simplification is really representing the data in a format that is cognitively more accessible to humans, but doesn't necessarily capture the full complexity of the data model structure. And this is something that I think we do on a regular basis without even noticing that we're doing it. When we're, for example, trying to do something like editing records, again, in our favorite spreadsheet application, because what we need to do there really is we need to take our records, which have a tree-like structure, and we have to simplify them into the tabular structure of spreadsheet applications, which basically only has columns and rows and none of the complex hierarchies that we have in the records. Now, the challenge when we're doing something like that is that there isn't really a single mapping from a more complex to a simpler data structure. So we always have to decide which one of the possible mappings we want to use, which is something that you're probably intimately familiar with already if you've ever used our CSV download functionality. So for example, if you're downloading records from MEI as CSV, the interface straightforwardly asks you, what do you want your rows to represent? Do you want them to be records? Do you want them to be provenances? And so on and so forth. Which data fields do you want to be in your columns? And that's exactly that process of simplification that you have to think about when you start working with the raw data. And you always have to keep in mind that simplification also means a loss of information, which is good. That's what you intend. You want to discard some information so that it's easier to work with the remaining information without all the clutter around it. But it's something you have to sort of keep in mind if you later want to manipulate the data and put it back into the database, because you have to remember, do I have all the information that I need to put things back into the right place? So for example, if I'm created a table for myself with, let's say, purchase prices and dates, but if I didn't include the information about which provenance blocks they belong to, I wouldn't be able to change things and put them back into the database later because I would lack that information about the structure. So here's just an illustration of that. That's our CSV download functionality, and you can see in the highlighted box that it asks you for that, what should your rows represent. Enrichment is sort of the other side of the coin. So a standard case of enrichment is when you're adding data from an external source, for example, another database or your own research. And so, for example, one thing that you might want to do is you have a spreadsheet of information about book purchases, and that spreadsheet contains ISTC numbers. And then you want to enrich that with bibliographic information about the titles, pulling them from the database from ISTC and putting them into the spreadsheet automatically, which is one of the things that we're also doing for the display in the web interface, right? We sort of take the identifiers and replace them with human readable information. So the challenge here is you need to make sure that you can match up the two data sources with one another, for example, by using unique identifiers. In that case, for example, the ISTC identifiers. And you also have to watch out for whether your two data sources may have incompatible structures. So one of them might be a tree, another one might be a graph, or they might just be very different trees. And then sometimes you have to, again, go back to the step of simplification and sort of work out what's the common core that I can use for working with both of these data sources. How can I put them together in a way that is manageable? So that is basically the process of working with the data. And now the question for us at the data conversion group is always, what's our role in this? And our role in this, I think, is to make life easier for everyone who tries to do that kind of work. So for both domain and technology experts that are somehow interested in working with CERL data, we want to make your life easier. That also includes ourselves. We also want to work with the data, and we also want to make our own life easier. And there's a few things we're already doing to do that. The first one is we provide various serialization formats for our data. So our data can be downloaded in the original JSON. We have an XML representation. We have RDF. So not in all databases. This is something that sort of differs from database to database, but the Thesaurus, for example, also has an RDF representation. And one of the benefits of having these various representations, these various serializations, is that this helps technology experts to quickly see what can be done computationally with the data. Because I think this is something that technology experts can sort of bring to the table when they're working on data like this, is their knowledge of structures like XML or JSON. They know what a tree is, what a graph is, what you can do with trees and graphs and tables, and sort of quickly see what's possible and what's impossible with the kind of data we have. On a more sort of domain side of things, we also try, especially with our RDF representation for the Thesaurus, to choose helpful ontologies that take our data model and connect it to well-known standards in the Glam world, to sort of do an initial translation of our data fields into well-established data fields. And one of the issues there is that standards really develop over time. So this is something that probably needs to be revisited. I've written a blog post on the topic, which I've also linked in the slides. And it's also something where I would definitely suggest that at CERL, we should probably form a small working group for people interested in the question of how to best present our data using existing ontologies. Because this is really an ongoing task and not a one-time decision. So we made a decision when we implemented it a couple of years back, and it was sort of best practice at the time, but then standards just develop, and you can't really predict which ones are going to be the ones that have a lot of uptake. So if you're in the session and this is the kind of thing that you're interested in, definitely talk to us. Just as an illustration, for example, one of the vocabularies that we're using in our RDF serialization for the Thesaurus is RDHR3, which is a great and well-established standard, but it's also, as you can see in the Open Metadata Registry, deprecated by now, so we'll probably have to think about replacing that. So that said, one of the questions that we constantly ask ourselves is, who is actually using our data in this way and how? So we know about the people who work on the databases. We have a lot of people contributing materials and editing, and that is really great, and we know about that. But it's sort of the other side of it, who's working with our raw data. So we try to compile a small bibliography of external projects, which is in the DCG paper on linked open data from May of this year. I don't know whether that one is actually publicly available or whether we just have that internally, but I'd be happy to share the bibliography with anyone who's interested. And what we found there is there's essentially two use cases that we found in literature for people working with our data. The first one is that people in their projects normalize their own data based on the CERL Thesaurus, which is great because that's what it's intended for. And the second use case is that people try to answer questions about large-scale bibliographic trends. And for that, I think mostly they use the Heritage of the Printed Book database, probably also just due to its sheer size with about 8 million records. So that's the things that we found. Then we also, of course, on top of that, we have our use cases inside CERL, some of which served as an inspiration for the examples earlier. So we do provide researchers with tabular representations of our data sets. We enrich externally created spreadsheets with data from our databases. And of course, also, if there are any questions that search cannot answer, then we also sometimes go into the database and see how we can answer them instead. One thing that we're also doing and that I'm really excited about is we are providing the MEI data for Coding Da Vinci, which is a regional hackathon in Hanover this year. There's a link if you're interested in hackathons. It's basically an event where hopefully some bright students will pick up the data set and then do some exciting things with it that we haven't imagined were even possible before. So that's what we found. One major player that we would expect to sort of see interacting with our data is the digital humanities community. And maybe some of you in the audience identify as belonging to the digital humanities community, in which case I'm very happy to have you here as well, because the DH community really offers a lot of ready-made tools for working with data, especially for secondary steps like visualization, analysis of data. You still usually need to do some data pre-processing, transformation, cleanup, all the usual steps when working with data, but there's also tools for that. And if you want to see some possibilities of employing these tools for working with CERL data, I can only direct you to Alex Janke's talk from 2018, which I've also linked in the slides. It's on YouTube. And he showed a few ways of just really straightforwardly grabbing CSV tables off the web interface and then turning them into interesting visualizations using some DH tools. I also want to point out here that we now have a DH working group at CERL, so if that's something that you might be interested in, then definitely come and join us. But generally so far, we have seen very little uptake of our data in the DH community. And there's a few options why that might be. The first one is it's there, but we don't know about it. So maybe somewhere in the Digital Humanities Lab, people are frantically working on CERL data and doing some really cool stuff with it. In which case, we'd be really happy if you know that, if you tell us about it, because we also want to know about the things that are going on there and see whether we can help with it. The second option is, I think, the one that's slightly more serious, which is that there might still be barriers to using our data. Now, the first one is that, as I said before, it's a very specific set of data that we have, and it requires quite a fair bit of domain expertise to work with it, to understand what kind of data is in the databases, what its limitations are, starting with simple things with like, why do we have separate printer records and person records in the sort of Thesaurus, which for some of you is probably a non-question, but for other people it might be like, yes, why? So that's one of the reasons why I think we might want to do something about communicating our data to the DH community. Also because it may simply not be well known enough. So I think there's some outreach still to be done. Because as I see it, there's still a lot of untapped potential in our data. There's a lot of things you could be doing with the data that isn't being done yet. And this is one of the reasons why what we would really like to work on over the coming months is work towards a so-called Glam Workbench for CERL. Now, the Glam Workbench is an idea that Tim Sherratt is presenting, for example, in a webinar at Liber this year. And what it is basically a collection of tools and building blocks for working with data from GLAM institutions, so galleries, libraries, archives, museums. So basically a collection of tools for working with cultural data. And we really like that idea because we think that it fits neatly with what we've seen so far, that we have really interesting data, but it could see some more use outside of CERL as well. So we envision something similar as Tim's Glam Workbench. Basically, what we want to have is examples for making use of our data outside the interface. We want to just show some use cases, highlight some things that you can do, and use those examples to explain our data from both perspectives. So both explain the domain side of things, what kind of data is this, what are the contents of it, how do you have to understand the data fields, but also the technology side of it. How is our data structured? What are the possibilities? How can you access it? What kinds of formats do we offer? How do they work? That kind of thing. And the hope would be that we could sort of position this as a translation between the CERL community and the DH community. We also have some thoughts on concrete implementations of this. So I think the standard way of doing this that Tim does and also other people do is a collection of Jupyter notebooks, which I'm going to say a little bit more about in the next slide. And this is something that libraries are doing right now. And you can see a couple of examples just sort of popping up at the moment. So here's a link to the National Library of Scotland's newly launched notebooks that's just a couple of days old. And so we want to sort of do the same thing, but for our particular data. And the idea would be for the data conversion group to provide some initial contents, but then aim to get more contributions from the wider CERL community and beyond, and sort of see what else people come up with and collect that together. Jupyter notebooks, I should probably say a couple of things about. Jupyter notebooks are basically documents that mix Python code or code in another programming language, but usually Python, with very detailed descriptions of that code, and that in that way make it possible to really explain every step conceptually and technically. So usually, if you're confronted with computer code and you're not a programmer, it's very hard to read it. There may be comments in there, but they are aimed at other developers. And so it's really not something that you can just sort of read through and understand what's going on. It's very hard to modify for yourself if you don't know what you're doing. And the idea of Jupyter Notebooks is that you really embed your code in so much description that you take the user by the hand and sort of lead them through the process and help them understand what's going on, even if they're not experts in whatever programming language you're working in. So for example, what you can see at the bottom of the slide here, you can see that the document starts with detailed comments, which include formatting. There's headings and there's links in there. You can even embed images. And then there's a little block of code, just a couple of lines, that essentially does the things that have just been described. And then there's again some commentary, and then there's some code again. And if the code outputs anything, it's just printed exactly below the code. So you can sort of follow along with the program step by step. And even if you don't read Python code, you can sort of follow along conceptually and then sort of translate what you've just seen and read into the code and see whether you could maybe modify it to do the things that you want to do with the data. What's also nice about Jupyter Notebooks is that they can be loaded in various environments as an interactive tool, so you can sort of click through them step by step and see what happens in the code. But you can also export them as a script, so if you want to later build them into larger workflows, you can just basically cut out the comments again and use them as normal Python scripts. And you can also export them to static reading versions, for example, a website or a PDF, which are then helpful as a sort of documentation of the data. So what I've done for this talk, in preparation of this talk, is I've played around with the possibilities and provided a few examples of Jupyter Notebooks. And I want to preface them with two caveats. The first one is I am not a book historian, so the questions I'm asking in these notebooks might seem silly to you, but they're just examples, and I'm sure you can come up with more appropriate questions from your domain and sort of translate between the two. And the second caveat is those are not perfect Jupyter notebooks either. They're sort of the work of 1 or 2 afternoons of just sort of sitting down and playing around with this little bit, just to give you an impression of the kind of thing that can be done. I'm not going to go into the Jupyter notebooks now, just sort of show you what kind of thing they produce, but they're all on the web, and we can either look at them in a question session or you can look at them later. I'm definitely keeping that up for a while. So the first example that I prepared is, what's a good name for a printer from Göttingen? So the question I'm asking in this notebook is, let's say I'm writing a novel set in historical Göttingen. I have a printer in it. I want to give him a name, and I want to give him an appropriate name. Basically, the question I'm asking is, how can I produce bar charts for categorical data in the CERL Thesaurus? So if I have some data fields that have categorical data values, how can I quickly get an overview of their distribution? And what the notebook does is it produces a bar chart like the one below, where you can, for example, see that the most common name for printers from Göttingen is Johann. That's based on data from the CERL Thesaurus. And the nice thing is, now that you have the notebook, you can sort of point it at any other data field in the CERL Thesaurus that has categorical data, and it will give you a bar chart for that data field. You don't have to know anything about Python. You just have to sort of look through a code, find the point where it points at that particular data field, replace it with any other data field in dot notation, and it just gives you a bar chart for that. So that's sort of the power of Jupyter Notebooks. You get one example, and then you sort of start thinking, how can I translate this to other questions? You can also do map visualizations. So this one, for example, is a map view of geo coordinates from the CERL Thesaurus. So here the question is, who came to Göttingen and where did they go? This basically takes persons who studied in Göttingen, and then it collects their birthplaces and death places and plots them on a map. And I'm sure you can think of other things, other geo coordinates in the CERL data that you could plot on a map like this. And the last one is, sometimes you also not only have geographical coordinates, but also movement between those coordinates. And of course, you can also plot something like this using Jupyter Notebooks. So this, for example, is using data from MEI to answer the question, how did these books come to Princeton? It essentially takes the books that are now in Princeton and then plots all the geocoordinates from the provenance information in those records, and then connects them by lines if they follow each other. So those are just 3 examples of I think many that one could do with the data that just give us capabilities of thinking about the data, of answering questions that go beyond what we can do in the web interface. And that is essentially what I wanted to share with you. And I'd be happy to hear questions and also discussion and maybe some ideas for Jupyter notebooks that we could be producing with more sensible questions, all those kinds of things. Thank you.
Wonderful. Thank you, Andreas. That was certainly for a novice like me very illuminating. Thank you for doing that presentation. So there are some questions that are coming in on the chat. Can you see the chat, or do you want me to read them out to you?
I can see the chat. Let me just quickly sort of change my setup. I'm going to take down the slides. So I'm going to stop sharing.
Yeah.
And then I'm going to put the chat here. And great. And so, then I also have my notes. Great. Excellent. So I'm just going to sort of go through the chat, if that's okay, and answer from the top.
Absolutely. Yeah.
And I'm also going to read it out because I'm not sure whether the chat is going to be in the recording. So the first question is, individual entries in the CERL Thesaurus can be downloaded as RDF, but is a dump of the entire data set as RDF or other formats also available? Or is the ample API the only way? Yeah, so this is an excellent question. We don't currently have an RDF dump of the entire thesaurus. The reason for that is because we don't actually store the RDF anywhere. We have a conversion routine that sort of automatically on the fly creates it from the internal JSON representation. That's the same for all our data serializations. So none of them are stored on the server. They're all generated on the fly. So there's a couple of ways one could get an RDF dump. So the first one would just be to download all of them one by one and then put them together. The other one would be to sort of download the JSON and then run the conversion routine on top of it, but I guess that makes little sense for you externally. So I think the currently, the only way of getting a dump of the entire thing is to either do the download of everything and put them together yourself, or talk to us and then we can think about how to produce one for you. We do in the long term, not in the long term, the midterm aim for getting a Sparkle endpoint integrated with the ample API. And in that case, we would then also be hosting the entire data set as an RDF graph. And then of course there would also be a straightforward data dump option plus the access through the dataset. But at the moment we're not doing that because there's some challenges in doing that because we have a lot of updates going on in the CT, so it's a very alive data set. It's basically being updated constantly, and so if we ever produce a dump, it becomes stale very quickly. And the same if we sort of provided a Sparkle endpoint based on any dump that we produce, we would sort of have to think about how often to run that or how to implement some kind of synchronization between the two. Does that answer your question? Otherwise,
so in that case, a Jupyter notebook is more helpful because it sort of makes use of the new data that is constantly added. I
mean, it kind of depends. Of course, you can also get an RDF dump and then build Jupyter notebooks on top of that. But yeah, so the way that I've implemented the Jupyter notebooks at the moment is that they run off the API and sort of pull the JSON directly from there.
Okay. Next question from John.
Good. This is more of a comment than a question, but I'd happily hear any comments you have. The example of the difficulty of editing when it's necessary to scroll a lot is something that has plagued the editors of MEI almost from the beginning. This is not an issue of using data, but of making it possible for editors to efficiently create more records faster and more accurately by not being distracted by the mechanics of physically moving around in the editing fields. There's of course a question of how the data are presented to the user, the editors, or maybe it's not really off topic. Yeah, so this is exactly the kind of thing that that I'm talking about. The problem here is that, of course, it really depends on what the particular editor is doing in that very moment, right? So if you are just creating a new record from scratch, it's very hard for the interface to know which data fields you're going to need. And so the solution that we have at the moment is to present you with the entire possibility. And that becomes slightly unwieldy because the data format of MEI is, of course, very complex because it's very detailed in a lot of things. And so it necessitates exactly the kind of cognitive labor of going through that, ignoring all the parts you don't want to have, and also the physical labor of scrolling. Yeah. And so this really depends, I think, on, so the question of whether you can avoid that by going the other route and maybe, for example, creating records outside the web interface in your own tools, really, I think, depends on whether there is a sort of stable subset of fields that you're working on. So if you say, look, I'm always working with those 5 fields, then it may be quicker to set up some kind of tool that allows you to just fill in these 5 fields and then somehow upload that to the database. Whereas if it really differs what fields you're filling in, then I'm not quite sure whether there is any good solution for that problem, but I'd be happy to discuss that in more detail. I think that that would be really neat to sort of have something there.
Yeah, so there is a an MEI working group or an Incnabula working group also looking at the tool MEI, which is used for recording provenance information, and they are currently reviewing a large document with suggestions for this environment. And certainly one of the questions is about scrolling through this enormous amount of options, and maybe a tabular approach of something could be envisaged, but it is being looked at, and I'd like to thank John for the question. So the next one from Nele.
So what actions have you taken to reach the user community, DH or other? It's probably something all institutions struggle with. Well, this talk is definitely a first step towards that. And I think we've only just begun that process of getting more involved with the DH community. So one of the things that I think we need to do in order to get more input from the DH community, to get talking to them more, is to start participating in their venues, in their conferences, presenting CERL data there. But as I said, it's something that we're just sort of beginning to do. And we're really hoping that exactly the kind of thing that I've proposed here, for example, setting up those notebooks, will also give us something that we can sort of take with us to those conferences, to those presentations, and say, look, we've already prepared this. Here's a few ideas what you can do with it. Now we would really like to see what else you can do with it, with your particular expertise.
Yes, and I think Nele is right that a lot of institutions are struggling with this. So there is maybe also some scope for using the DH community working group that Andreas mentioned in CERL, for us as a community to look at how we are making our data sets more visible in this respect. And maybe also in talking a little bit more with each other about how we're making them visible and presenting them, so that there is some sort of a unified approach that could be created together. So if Nele wants to have another chat about this offline, then I'd be very, very welcome to talk to her about this. Be very useful.
And also, I mean, I don't really see the entire audience now on my screen. But if you are in the audience and you are a member of the DH community and you have helpful tips on how to talk to you and your colleagues, please do share.
Absolutely. Are there any more questions?
Yes, I have one here. Will the upcoming Sparkle endpoint also include a reconciliation service for OpenRefine? I don't know yet. I mean, definitely something that would be really nice to have, and we'll have to have a look into how much effort it would be to implement that and what the priority is. Can't answer it yet. Sorry. Have you considered alternatives to the Jupyter notebooks that is relatively easy to use tools to work with the data? So I think we have to make a small distinction there between tools for working with the data and something like the notebooks that is really about showing you how to build your own tools. Because we do have a tool for working with the data that we are developing and that we think is easy to use and that we're always working on making even easier to use, and that is the web interface. So that is sort of the straightforward approach that we take in making it possible to work with the data. And so I don't think that we would want to start creating a parallel tool set that somehow does something slightly different than the web interface, and then we would have to maintain both of them. And the notebooks, I think, are much more geared towards showing people how the data works so they can then start building their own tools. Now, one of the things that I've done in creating those notebooks, and I think that might be maybe something that sort of relates to what you're asking about, is I am writing currently a little Python library that allows easy access to the AMPL API without getting bogged down in the details of requesting things and parsing the records and all that kind of stuff. So that, of course, is only useful if you already know Python. But it would definitely be something I think that is helpful for people who do know some Python, who don't want to, who want some easy access to our data from that. But I think in both cases, it's always aimed slightly more at people who want to play around with the data a little bit in some kind of framework that allows more flexibility than ready-made tools. Because for the ready-made tools, I think we do already offer a lot of things, first in the web interface, but also if you download the data from the web interface, a lot of it is sort of readily usable in other tools that already exist. And I think if you want to see that, I can only point you towards Alex's presentation again from 2018, because there he shows exactly that, so how you can take tools. I think he's using, for example, Gephi, that are already out there, that are well established, and work with our data with that.
Very good. Is there anything else that people would like to ask? In that case, I'm going to repeat that this was recorded, and the recording will be put on the CERL YouTube channel eventually. We are also making the slides available so that you can actually click through on the links. I would like to thank Andreas again, because this was a really, really helpful introduction to what you can, how you can approach CERL data.
Thank you all for participating, and thank you for the questions. And I'm very happy to talk about all of these things in more detail, so you can always reach me by email or on Skype or on Twitter and so on and so forth if you want to discuss any of these questions in more detail.
Wonderful. It's always a bit strange to end these things, but thank you all for being here, and we are going to let you go if you want.